Type number 3, change of order of integration. So many times it is not possible to integrate with respect to x first or y first. Suppose we want to integrate with respect to y first and it is not possible to integrate with respect to y first, then we have to change the order of integration. That will be clear from first few examples. So let me start with the first example. See the first example. Evaluate from 0 to infinity x to infinity e raised to minus y divided by y dy dx. So see how the integral is. The internal limits are limits from x to infinity, so they are the limits of y, and the terms in y are e raised to minus y divided by y dy, which cannot be integrated by any known formula. So in simple words, it is not possible to integrate with respect to y first, and whereas if it is required to integrate with respect to x first, there is only one term in x, that is dx, and that can be integrated. So integration with respect to y first is not possible, and we can integrate with respect to x first. Therefore we have to change the order of integration. Merely changing the order of limits will be not sufficient. See what the procedure is. For that we have to consider the area of integration, consider the limits x equal to 0 to x equal to infinity, y equal to x to y equal to infinity. All are the straight lines. Draw the straight lines. They are drawn in this way. X-axis, y-axis. X-axis is known as y equal to 0, then y equal to infinity, x equal to 0, and then x equal to infinity. The required area is the area of the triangle. Okay, A is the point of intersection. A is infinity, infinity. Now we want to change the order. Previously it was integration with respect to y, now integrate with respect to x first. Now see how the order is changed. Integration with respect to x first and then with respect to y. Outer limits are limits of y, therefore they are constant numbers, minimum value of y and maximum value of y, y equal to 0 and y equal to infinity. To find the limits of x, consider a strip parallel to the x-axis. Okay, the strip starts here. Here means along the y-axis, that is from x equal to 0 up to the straight line x equal to y. So the limits are y equal to 0 to y equal to infinity and x equal to 0 to x equal to y. Now with the changed order of integration, see how we can solve the integral. Integration with respect to x first, limits are x equal to 0 to y, limits of y are 0 to infinity, e raised to minus y divided by y, constant integration of dx is x, the limits are substituted, and then y is cancelled. Then we have e raised to minus y only, that can be integrated directly, minus of e raised to minus y, limits are substituted, and the final answer is obtained, that is 1. Next example, integration from 0 to 1, then 0 to root of 1 minus y, cos inverse root of 1 minus x square minus y square, 1 minus x square. So internal limits are limits of x equal to 0 to root of 1 minus y square. So integration with respect to x first is not possible, since each and every term cos inverse x, 1 minus x square, 1 minus x square minus y square contain x. Whereas if you want to integrate with respect to y first, see we have only one term in y, that is 1 upon root of 1 minus x square minus y square, that can be integrated. So we have to change the order of integration. So consider the area of integration, that is y equal to 0 to y equal to 1, x equal to 0 to x equal to root of 1 minus y square. Square on both sides simplify, will get x square plus y square equal to 1. Circle having center at 0, 0 and radius is 1. So to find the required area, draw the circle. X square plus y square equal to 1. Then the limits are y equal to 0, y equal to 1, draw the lines. Then x equal to 0 up to x equal to circle. So the circle in first quadrant is the area of integration. Now change the order of integration. Now it integrate with respect to y first and then with respect to x. So outer limits are limits of x, they are constant numbers, minimum value of x for the area is x equal to 0, maximum value of x is 1, x equal to 0 to x equal to 1. To find the limits of y, consider a strip in the area parallel to the y-axis. The strip starts from y equal to 0, that is lower limit. Strip ends at a circle, so value of y from the circle root of 1 minus x square. So limits x equal to 0 to 1, y equal to 0 to root of 1 minus x square. The terms in x are constant. Cos inverse x divided by root of 1 minus x square constant. Integration of 1 upon root of 1 minus x square minus y square. Using the formula 1 upon root of a square minus y square dy, that is equal to sin inverse of x by a. Here a is equal to root of 1 minus x square. So using the formula, the x equal to 0 to 1 as it is cos inverse x divided by root of 1 minus x square, as it is sin inverse of y divided by a. A is 1 minus root of 1 minus x square. Then the upper limit is substituted. We have sin inverse of 1, lower limit 0, so sin inverse 0. Sin inverse of 1 is pi by 2, sin inverse of 0 is 0, so pi by 2 is written outside. Then we have cos inverse x divided by root of 1 minus x square. T equal to cos inverse x is substituted. Dt equal to minus dx divided by root of 1 minus x square. Limits are changed. All these changed limits are substituted, and we have t dt, that is integrated to get the answer pi cube divided by 16.